In this video, you will learn some basic rigging devices, as well as some basic rigging techniques, and how to safely apply.
In the world of rigging, there are three basic hitches: the straight leg vertical hitch, the choker hitch, and the basket hitch. Regardless of the type of sling or hitch being used, the user must ensure that the sling and rigging hardware have working load limits that exceed the actual loading imposed on the sling and the rigging hardware attached. Also, crane operators and riggers should be aware that by moving a load harshly, you can easily double the loading on the slings and hardware attached.
Synthetic or steel-based, web or round, wire rope, chain mesh. Slings are an essential part of any lifting and rigging situation, but can be confusing, and this confusion can create an unsafe situation on one of your job sites. So what sling is the right one for the job? From materials, shapes, and weight ratings to most common uses, we're going to cover the what's what on slings built for any task. There are 5 common types of slings found on job sites. They are broken into 2 main categories: synthetic and steel-based. Let's start with the most common types of slings. Synthetic. There are 2 main types of synthetic slings: web and round. We'll start with the synthetic web sling. Synthetic web slings are flat synthetic lifting products made of webbing material and feature fittings like flat or twisted eyes on each end. Synthetic web slings are inexpensive, lightweight, durable, and strong, as well as flexible, easy to handle, and can adjust to irregular loads while maintaining a secure grip. Because of this, they are the most versatile and widely used multi-purpose lifting slings. Synthetic slings are exceptionally resistant to rot or mildew and are not normally affected by grease or oil. They can also be fabricated with wide load-bearing surfaces and are still easy to rig and handle. Most web slings are available in thicknesses from 1 to 4 ply and have a capacity from 950 to over 200,000 pounds. Synthetic web slings are broken into 2 main groups: nylon and polyester. Nylon web slings come in either regular or heavy-duty webbing and will stretch approximately 10% at the working load limit. They can also be used in alkaline environments. Nylon slings cannot be used in acidic environments or around any type of bleaching agent. Polyester web slings are the most popular, cost-effective sling available and come in standard and heavy-duty webbing and stretch approximately 7% at the working load limit. These slings can be used in most acidic environments or when bleaching agents are present, but they cannot be used in alkaline conditions. They also are non-sparking, non-conductive, and safe to be used in explosive atmospheres. To improve either nylon or polyester slings' durability, wear pads are common to protect against cutting, puncturing, or abrasion. Web slings, either nylon or polyester, are used in nearly every industry and for lifting everything from rocks for landscaping to pipes and beams for skyscrapers. Now let's talk about synthetic round slings. Synthetic round slings are most commonly made of a continuous loop of polyester yarn covered by a double-walled tubular polyester jacket and are color-coded for easy identification. They are especially useful for lifting tubes, pipes, or materials that could be damaged with other rougher slings. Round slings can be used in chokers, basket, or vertical hitches. Synthetic round slings normally range in body diameters from 5/8 to 3 5/8 inches, but custom slings are also common. Synthetic round slings have lifting capacities from 2,600 to over 180,000 pounds. Some of the advantages of round slings are the jacket protects from corrosion, abrasion, and UV degradation, as well as securely gripping the load. The jacket also resists moisture absorption, rot, and mildew, and their low stretch makes them great for lifts with low headroom. Next, we're going to cover steel-based slings. There are 3 types of steel-based slings: chain, wire rope, and mesh. This is an alloy chain sling. Alloy chain slings are the most durable of all sling types. They are well suited for extremely heavy or rugged loads, as well as high temperatures that would destroy other types of slings. Alloy chain slings are made up of 4 parts: master link, ID tag, sling legs, and lifting attachments. Each of these parts has a few different options depending on their intended use. Like wire rope slings, alloy chain slings can have anywhere from 1 to 4 sling legs. Alloy chain slings are easy to inspect, can be repaired by replacing individual links or link segments. After proof testing, they can be recertified to be used in the field. They're also easily adjustable, which can be done by removing links or link segments. Alloy chain slings can be found in 9/32 of an inch to 1.5 inches and have a lifting capacity between 3,500 pounds and over 90 tons. While these slings are perfect for the most intense jobs, they are typically more expensive, weigh more, and have a tendency to damage the load. Alloy chain slings are mainly used when other slings are likely to be damaged, like in foundries, steel mills, and heavy machine shops. Up next is the wire rope sling. The low cost and ease of use make wire rope slings popular among crews, and they excel in lifts where protecting a fragile load is essential. Typical wire rope slings consist of 4 main parts: individual wires, multi-wire strands, a fiber or steel core, and lubrication. The individual wires are braided into strands, which are then laid around a core in a helical pattern to produce the sling. There are different types of cores, strand patterns, and lays depending on the sling, meaning that many wire rope slings are designed specifically for lifting certain materials or lifting in certain situations. Overall, these slings are more durable than synthetic slings and more cost-effective than chain slings. They have the lowest cost per ton of lift of all slings and are known for their strength, ability to bend without distortion, and to hold up against abuse or abrasive wear. If your wire rope sling does get damaged, the master links and hooks can be reused, which helps cut down on replacement costs. Wire rope slings can range from 1/4 of an inch to 3 inches in diameter and have capacities from 1,400 pounds to 153 tons. Traditionally, wire rope slings are used for hot materials, crane or elevator wires, and general construction where loads aren't in danger of being damaged when lifted. They are mainly used in machine shops, steel warehouses, and other metalworking industries. In order for any sling to be used on a job site, regardless of the type, they are required to have a legible and present safety tag. Any sling without this must be removed from service and replaced.
Shackles are commonly used to attach a sling to a load. A screw pin shackle, which consists of 2 pieces, the shackle bow and the pin, is often the shackle of choice in pick-and-place applications. Crosby shackles discussed in this video are manufactured with a patented quick check feature that incorporates 2 marks forged into the shackle bow at 45-degree angles from vertical on each side. These quick check marks are used to quickly check the angle of a single leg hitch when the shackle pin is secured and the pull of the load is off vertical, resulting in a side loading circumstance. These quick check marks are also utilized to quickly check the approximate included angle of a 2-leg hitch. Before selecting the correct piece of rigging hardware for your application, you should determine that the diameter or width of the rigging hardware being used is bigger than the diameter of the wire rope sling. An example would be, if you're using a 20mm diameter wire rope sling, the shackle attached to the wire rope sling eye must be at least 7/8 of an inch or 22mm in diameter. It is also worth noting that the European EN standard requires that the object in the eye of the soft eye sling be not less than twice the nominal diameter of the wire rope. Once the shackle is connected to the sling, the shackle is attached to the load with the screw pin in contact with the connection point on the load, as shown. The screw pin is then rotated to a minimum of hand tight into the ear of the shackle body with full thread engagement before lifting or movement of the load begins. The load should be centered on the shackles to prevent side loading, and the screw pin must be tightened before each pick.
The rigging triangle is a key consideration when making connections to loads and load hooks. The rigging triangle is formed anytime 2 or more slings are connected to a load and load hook. Whether the slings are chain, wire rope, or synthetic, the best practices are based on the same principles. Focusing on the horizontal sling angles formed in the rigging triangle highlights several best practices that are very valuable to the rigger. It is important to remember that as the rigging triangle becomes flatter, the horizontal sling angles become smaller. As the horizontal sling angle becomes smaller, even though the lifting load remains the same, the crushing loads increase. The sling tension is the result of both lifting and crushing. This means as the sling angle becomes smaller, the sling tension and the load at the load connections increase, and the crushing forces pulling the slings toward the COG also increase. The result is that at 60 degrees horizontal sling angle, the sling tension is multiplied by 1.15. At 45 degrees, the tension is multiplied by 1.41. And at 30 degrees horizontal sling angle, the tension is multiplied by 2. These facts lead us to recognize the best practice for selecting proper sling angles. For multiple leg bridles, whether the connection is direct to the load with hardware or choker and basket hitches, a horizontal sling angle of 60 degrees is the angle of choice. This is because the multiplier is only 1.15, the side or angular load on the load connections is limited, and the crushing load is minimal. A tool to use to verify that the slings are rigged to 60 degrees is to remember that a 60-degree sling angle is formed when an equilateral triangle is created. That means that the sling lengths will be equal to the distance between pick points. It is also useful to remember that increasing the sling length will increase the horizontal sling angle and improve the rigging situation. It must be noted that 60 degrees horizontal sling angle is the best choice, but is also the minimum angle for single wrap chokers and single wrap baskets. There are circumstances where a 60-degree horizontal sling angle is not possible. When this occurs, there are guidelines for the minimum sling angles that can be used with extreme care. 45 degrees is an acceptable horizontal sling angle only for bridles connected hardware to hardware and for double wrap choker hitches. At 45 degrees, the sling multiplier increases to 1.41 times. The crushing forces pull the slings toward the load center, and the angular or side loading is very significant. 30 degrees is never a desirable angle. However, 30 degrees horizontal sling angle can be used with extreme care when connecting hardware to hardware. Never use choker or basket hitches at this minimal angle. Remember, best practice calls for a horizontal sling angle of 60 degrees or larger for all connections and hitches, basket or choker, single or double wrap. One of the basic hitches when using wire rope slings is called the choker hitch. The choker hitch is formed when one leg of the sling connects back to itself. A wire rope choker hitch does not have the full capacity of the straight leg vertical hitch. The choker hitch capacity is approximately 75% of the straight leg vertical hitch. This capacity assumes that the angle of choke is at least 120 degrees. Some standards, such as API RP 2D offshore environments, requires slings of all types when used in a choker hitch application to have a capacity of no more than 70% of the straight leg vertical hitch. The sling's capacity is reduced further if the angle of choke is less than 120 degrees. In fact, if the sling is bent back over itself, with the angle of its choke approaching 0 degrees, the sling's capacity would be reduced by 50%. A single-leg choker hitch is easy and convenient to use and can work well on simple, short loads, but it does not always provide the load control and grip needed for safe and effective rigging. Sometimes, multiple leg slings choked on both ends of the load are required to gain the load control necessary. If choker hitches are used, the user must always ensure that the slings cannot slip or slide along the load. It is important to note that a standard choker hitch does not provide a full 360-degree contact with the load. A double wrap choker hitch is better for handling those hard-to-handle loads and bundles of materials like rods or pipe that require more sling contact to hold them in place. Make sure the slings do not overlap at the bottom of the load when you form the double wrap choker. As a final note, the user should always ensure that the wire rope slings are protected from edges, corners, protrusions, or abrasive surfaces in order to protect the sling from any damage.
Crosby screw pin and bolt type shackles, sizes 3/16 inch to 3 inch, can be used in side loading applications when installed correctly with the pin secure and the direction of loading is in the plane of the shackle bow, as shown in Crosby's general catalog. However, a reduction in the shackle's working load limit is required when side loading occurs. It is important to point out that side loading of a round pin shackle is never allowed. It is secured by a cotter pin that could shear when side loaded. When the direction of pull is vertical, perpendicular to the shackle pin, no reduction in the shackle's working load limit is required. However, if the shackle is subjected to a side load of 45 degrees from vertical, the shackle's working load limit must be reduced to 70% of the shackle's rated capacity. Thus, when a screw pin or bolt type shackle is subjected to a 45-degree side load, the shackle loses 30% of its published working load limit. If the screw pin or bolt type shackle is subjected to a 90-degree side load from vertical, the adjusted working load limit would be 50% of the shackle's rated capacity. Thus, when a screw pin or bolt type shackle is subjected to a 90-degree side load, the shackle loses 50% of its published working load limit. It is important to state that when a shackle is used as a collector ring to gather multiple sling legs as shown, this is not considered a side loading circumstance. When the slings are collected with the included angle not greater than 120 degrees, this would be considered a balanced load, and the shackle's working load limit would not require a reduction.
Using two slings in a true inline load, each side will see half the total weight. From the Crosby lifting guide, notice that for a 90-degree horizontal sling angle, the load angle factor is 1. In this example, the total load is 5,000 pounds, which is divided by 2 for each sling leg, and then multiplying by the load factor, which is 1. The result is that each side lifts 2,500 pounds. To select the proper bolt, refer to the Crosby lifting guide. Note that the panel does not mention the S279 because the information is the same for all Crosby shoulder eye bolts. We need to select an eye bolt whose working load limit exceeds the required load of 2,500 pounds, which in this case is a 1/2 inch machinery eye bolt with an inline working load limit of 2,600 pounds. Let's now look at how increasing the horizontal angle affects the size fitting required. For 60 degrees, the load angle factor is 1.155. Again, we divide the load of 5,000 pounds by 2 and then multiply by the load factor to determine the load each sling leg will see. In this case, each sling is loaded to 2,887.5 pounds. We will round the calculated load to 2,888 pounds. Referring to the lifting guide, you will notice 4 columns showing the rated capacity of Crosby shoulder eye bolts at various horizontal angles. Crosby shoulder eye bolts have a catalog rating based on inline loading. As side loading occurs on the eye bolts, they must be down-rated. The smaller the horizontal angle, the greater the reduction in the working load limit. As an example, let's look at the 1/4 inch size. At 90 degrees or inline, the rating is 650 pounds. As the horizontal angle changes, so does the resulting working load limit of the eye bolt. At 60 degrees, the rating is 420 pounds. At 45 degrees, the rating is 195 pounds. And at horizontal angles less than 45 degrees, the working load limit has been reduced to 160 pounds.